Distance from a point to a line. I have 3 examples where we will explore how to find the distance from any coordinate to a line. And when we do that, we are finding the shortest distance from the point to a line, which is a straight line perpendicular to the line given. So we're going to try to find the distance of that green line. And that distance will be found by using the length formula or the distance formula, which is Pythagorean theorem. So it's the change of the x squared plus the change of the y squared. The first example, we're going to find the distance from the origin to a line. So our coordinate will be 0, 0. So ultimately, we want to know this point of intersection so that we can use it to find the distance between the origin and the line. So we're all leading up to using the length formula. Change of x squared minus the change of y squared. So the first thing we have to do is find the equation of this now blue line. And once we have that equation, we can use a systems of equations to find the point of intersection. So here we go, finding the equation of that blue line. To find the equation of that blue line, we need 2 things. We need a point and a slope. Well, we have the point. To find the slope, we're going to use the perpendicular slope of the line given. So our first step is perpendicular slope of y equals 2x minus 10. Well, the slope is given as 2, so the perpendicular slope would be to flip the fraction, change the sign, and that slope would be 1/2. We are now going to use point slope. We have a slope of -1/2, and we have our point of 0, 0. Taking those 2 values into point slope, that formula, remember, is the change of y equaling slope times the change of x. Plug in the numbers. Slope is -1/2. X and y are both 0. So the equation of the perpendicular line will be y equals -1/2 x. The line that we are given is y equals 2x minus 10. And our next step now is to find the point of intersection, the POI. So I'm going to stack those 2 equations on top of each other. And step 2 is to find, again, the POI. So equation number 1, doesn't really matter which one is which, will be 2x minus 10. Equation number 2 will be y equals -1/2 x. You can use elimination or substitution. I think at this point it might be easier to use elimination. So I'm going to go 1 into 2 or 2 into 1. So I'll get 2x minus 10 equals -1/2 x. To find x, I'm going to clear my fraction first. So I'm going to multiply both sides by 2. And this will clear the fraction on the right. So I'll get 4x minus 20 equals, the 2's cancel out, -x. I'll bring the x over to the left, so it becomes positive. I'll take the 20 to the right, so it becomes positive. Tidy the left-hand side. 5x equals 20. Divide both sides by 5, and my x value is 4. I can use any equation I want to find my y value. I think I'll use equation number 2. So y equals negative 1/2 of 4. So y equals negative 4 over 2. Y equals negative 2. So my POI is 4, negative 2. I just have one thing left to do, and that is actually find the distance. So one more column, third item, distance. To use the distance formula, you need 2 points. We're starting from the origin, so the first point is 0, 0, and the second point or coordinate is 4, negative 2. So now I write my distance formula or length formula. I know that it's the change of x, so it's 4 minus 0 all squared plus the change of y, so negative 2 minus 0 all squared. This will equal now 4 squared plus negative 2 squared. So we've got 16 plus 4. So our exact answer would be the square root of 20. That's the exact value. And to find the approximate value, I just take the square root of that. I'm going to go to the nearest tenth, so it's going to be approximately 4.5. Now, if you know the equation of a circle, you could recognize that this could be done a little bit simpler using the equation of a circle. X squared plus y squared equals the radius squared, because that's what we're finding if we're starting from 0, 0. So then it would be 4 squared plus negative 2 squared equals r squared. 16 plus 4 equals r squared. 20 equals r squared. The actual radius or the distance in this point would be square root of 20, and the approximate radius would be 4.5. On to our second example. So now we're not starting at the origin, we are starting outside of it, and we're given the equation of the line in standard form. The steps are the same. So the first thing we have to do is figure out the equation of this perpendicular line, so we then can find the point of intersection, and lastly, we can find the distance using the length formula. So on to step 1, finding the equation of the blue line. Well, we need a point and a slope. We have a point, and we can get our slope from the equation given. We just have to find the perpendicular slope of that. So step number 1, creating that blue equation. First step is to find the perpendicular slope of the line given. So x plus y minus 5 equals 0. Put it into slope y-intercept form, and that gives you a slope of negative 1 and a perpendicular slope of 1. So now you have a coordinate and a slope. So here is the coordinate, the one given, negative 1, 3, and a slope of 1. Going into point slope now, I have enough information. So y minus 3 equals 1, x minus negative 1. I'm going to tidy up the right-hand side. If I'm multiplying through by 1, it's exactly what I see. So I'll tidy up the bracket, and I'll get x plus 1 because of the double negative. I'm going to bring my x over, it becomes negative, add the y, and I'll put the numbers on the right. So negative x plus y equals 4. The reason I'm putting it in that form is I know that I have to do a systems of equations later on. So the equation now given is x plus y minus 5 equals 0. I'm also going to put it in the same format, which means the 5 goes across the equal sign, and now I have my two equations. The next step is to find the POI. So I'm going to stack my equations. Equation number 1, negative x plus y equals 4. Equation 2, x plus y equals 5. I think I'll solve using elimination at this point, and I'm going to add them together. So my x's disappear, and I will get 2y equals 9. Divide both by 2, and I will get y equals 4.5. I think I'll use it as a decimal, 4.5. To find x, I can use any equation I want. I think I will use number 2 in this case. So x plus 4.5 equals 5. Push the 4.5 across to solve for x, and x equals 0.5. You could use fractions if that's your pleasure. In this case, I think decimals will be a little bit simpler, a little more direct. So we're on to our last step. We have our two coordinates, and now we're going to find the distance. Just going back to our graph here. So what we've done is we found the equation of the blue line. We found the POI. And the last thing we're going to do now is use the distance formula to calculate how far it is from the original coordinate to the line. And my two coordinates are the one given, which I've just forgotten, negative 1, 3. And the one we just found, which is 0.5 and 4.5. So the distance formula, length equals, so now the change of the x, 0.5 minus negative 1 all squared, and then 4.5 minus 3 all squared. Here we go. Negative 5 minus minus becomes 0.5 plus 1 all squared, and 4.5 minus 3 becomes 1.5 all squared. Tidy up the left bracket, so that also is 1.5 squared. 1.5 squared is 2.25. So I need to write that again. So 2.25 plus 2.25 gives me a square root of 4.5. And there is your exact answer. If you want an approximate answer, square root it to the nearest tenth would be 2.1. Okay, so one more time, just the process. What you're doing is, first of all, finding the equation of the line that takes you from the point to the line itself. Then you find the POI. Then you find the distance. And now my last example. We're going to find the distance from any point to a line through two other points. So we're trying to find the distance from P, which will be 2, negative 3, to the line that connects 6, 5 and 9, -4. So I'm just going to draw a sketchy line through my two coordinates. And we are trying to find the same thing now as the other two examples. We want the shortest distance, which will be a line drawn perpendicular to it. The first step will be to find the equation of the green line. The second step will be to find the POI. The third step will be to find the length. So first step is the equation of the line. Second step is the POI. Third step is the distance. Okay, first step, finding the equation of that green line. To find the equation of the green line, we need the perpendicular slope of the pink one. So that is our first thing to do. We're going to find the perpendicular slope of the pink line. And I may as well use pink as a color. So, first step, find that perpendicular slope. So slope is the change of y over the change of x. So -4 minus 5 over 9 minus 6 becomes -9 over 3 becomes -3. So while I have that slope, I can certainly indicate what the perpendicular slope is. But now that I have the slope, I may as well find the equation of the pink line. So to do that, I'm going to use my point slope formula. I know my slope is -3. And it doesn't matter which coordinate I use, but I think I'll use 6 and 5. So y minus 5 equals the slope of -3, x minus 6. Y minus 5, expand, -3x plus 18. I'm going to put my 3x to the left, bring down the y, bring down the 18, put the 5 across, it now becomes positive, and now I have the equation of my pink line. At this point, I can find the equation of my green line. The green line has the perpendicular slope of the pink one, so that slope is the perpendicular slope of -3, so that perpendicular slope will be 1/3. And I have a point, and that point is 2, -3. So now I can find the equation of my green line using point slope. So y minus -3, my slope of a third, x minus 2. Tidy up the left-hand side, the double negative becomes a positive, and the right-hand side remains the same. I'm going to clear my fraction by multiplying both sides by 3. These 3's will cancel each other out and become 1. I'll expand the left, 3y plus 9. Expand the right. There's no need really to write the 1. 1 times anything is exactly what you have, so it becomes x minus 2. I'll put it in the same form as 3x plus y equals 23, so I can then use a system of equations. So I'll bring x across, it becomes -3y, leave the -2, bring the 9 across, it becomes negative. And now I have my second equation. So I have two equations. Going back to our chart, I now have the pink equation, I have the green equation, and I'm going to find now the point of intersection. To do that, I'm going to use a system of equations. It's becoming quite colorful. I'm going to use blue. So my two equations stacked on top of each other to find the POI are equation number 1, 3x plus y equals 23, and equation number 2, negative x plus 3y, negative x plus 3y equals negative 11. And for this one, I think what I'll do is solve for x in equation number 2. I'll get a little fancy. I'm going to take the x across to the other side and bring the 11 to the left. So I'm taking 11 to the left and x to the right, and both those signs now will change. So now that I've isolated x, I'm going to go from the second equation into the first. So now it becomes 3x, which is 3y plus 11, plus y equals 23. Expand. Collect like terms. The 33 gets pushed to the right, becomes negative. That should be a y there. Equals negative 10. Divide both sides by 10. And y equals negative 1. I can use any equation I want to solve for x, but it's already isolated for me in equation number 2. So now it becomes 3 times y, which is negative 1, plus 11 equals x. Negative 3 plus 11, so 8 is x. So my POI is 8, negative 1. And that brings us to our last step, which is to find the distance. And to find distance, we will use the length formula. So we have two coordinates, 8, negative 1, which we just found, and the original coordinate, 2, negative 3. Now we plug those into our length formula, which is the change of x, so 2 minus 8, all squared, plus the change of y, negative 3 minus negative 1, bracket squared. 2 minus 8 is negative 6. Negative 3 minus 1 is 3, negative 3 plus 1, so that's negative 2. This will become 36 plus 4, so your exact value is the square root of 40. And if you were to square root that, you would get an approximate value of 6.3. And we are done. Thanks for listening.